All right. So we're gonna do two things today. We're gonna start working and talking about the final project, and then we're gonna try to figure out if machines are gonna take over the world. It's kind of sort of stuff. Just a quick remind or point out announcement. Um, Science Scholastica has been awarded $1,000 scholarship from Mini Analytics, which is the Minnesota Analytics Association here, and we've got to give it away to someone. So we have $1,000, and one of you should get it here, and so we've got to give it out by the end of the school year. So in the next a week or so, you should consider filling out the short application for a job where the scholarship is $1,000 for your tuition next year. If you're a graduating senior, I'm sorry, that's not going to work for you. And it's supposed to be awarded to someone who's passionate about a career in data science, regardless of their major or minor. And someone who has done or demonstrated some commitment to data analytics or engagement in data analytics. So if you've been to a data analytics competition or gone to a data analytics talk or conference or anything like that, you should consider applying for this scholarship. It's nice because, I mean, it's just someone at St. Scholastica who is doing data analytics stuff. So it's a smaller pool. You're not competing against everyone across the United States or everyone across Minnesota. It's just, basically the students in this room and a couple other, classes. So consider applying for that. Okay, let's talk final project. So there isn't a final exam in this class. Instead, there's a final project, which basically is a final paper that you have to write, a final research paper. And you have to present it at the CIS showcase, which is the Monday afternoon, the first Monday of finals here. It's a 2,000 word plus essay paper, and we'll lay out, and we have a basic outline for the paper here. It's kind of a standard, what we call a research paper. You introduce your topic, you do a literature review, you talk about what other people have done in this area. You then do some of your own research, talk about how you're going to do that, how and what data you're going to use or collect. Then you're going to show your results and come to some conclusion, and then you have a bibliography for it. So that's the basic layout of the sort of research paper. We've done a couple kind of projects getting us kind of close to this, kind of prep for this. So when we were doing convolutional neural networks, we had you create a hypothesis about what you could do to improve a convolutional neural network, and then kind of use a collab to test out that hypothesis and write about it. So that was one. And then I think it was last project, again, we had you think about a hypothesis. We talked about what would be your independent and dependent variable that you're going to test. You're thinking, if I change this independent variable, and then it will affect this dependent variable idea, and setting up kind of a scientific experiment. So that's your goal here, is you have to do the same sort of stuff as it's basically a scientific research position. I used to require students to have an associated collab, a notebook with data in it. You can still do that, and I expect a number of you will. You could also just use an LLM directly or an AI model directly and do experiments on that in or outside of a collab. The easiest way to do this, or think of this, I think, is to think about something we've done in class already that you want to do a deeper dive into, where we worked with some of the parameters, some of the modifications, but you want to go into more detail on this. We already maybe have a collab set up with some data in it, and you want to just build on that. So that's probably the simplest, most straightforward approach. We typically have some students who want to do some new data, something new, or try out something else here. Sometimes we'll have students will look at the Kaggle competitions and think, maybe I'll just, win $100,000 by doing one of these Kaggle competitions here. And again, sometimes I can help with setting up or running one of these, or if you're interested in that. If you're interested in some other areas, we've done last year, we had a couple students interested in sea turtles. So I worked with them. There's a sea turtle image data set in Kaggle. And so we got that. And then they did, identifying sea turtle faces in images and trained a network to find sea turtles in there. And again, it was based on a Kaggle competition. Now, something like that, if you want to take that on, that's fine. But talk to me and I can help you do some of the setup for that if you want here. Now, the project's broken up into a couple parts. So this Sunday, the project outline is due. And then the Sunday, May 5th, the final paper is due. And then the presentation is May 6th here. The presentation isn't a big presentation. If you're a computer student, you've probably been to the CIS showcase a couple times and you know how it works. But if you're not a computer major, you may not have been to it. Basically, it's a pizza party where we sit around each other's computers and look at things. So everyone, we fill up these labs with students, and you bring up your paper or your whatever you're working on, your program. There'll be games from the game design students here. So all the computers will have something on them, and you'll wander around and go to one computer or another, and people will come up to you at your computer and say, what class is this for? And you have a little note, little signs on your computer, what class you're in, and they'll say, what research did you do? And you'll bring up your paper or your notebook or whatever and talk to them for a couple minutes while eating pizza or whatever we have that night. So again, it's a presentation in that, it's kind of more like a poster session or a sharing session. You're not getting up in front of the whole group giving a formal presentation. It's more, we call it an open house there. So that's what you have to present. But online students will record a video of their presentation and just share it with me, and we'll try to share that at the open house, or we call it a showcase instead. So I have a couple of sample final papers from past years here that you can look at to kind of get ideas. Some different topics are here. So again, you can look at anything we've done in class. So like we did classifications with with k-nearest neighbors or decision trees. You can go back and do that. We talked about clustering with k-means clustering. We did convolutional neural networks and did different image recognition or things like that. We talked about long-short recurrent neural networks. We talked about prompt engineering, AI agents, RAG, recurrent augmented generation. We talk about bias in AI models. Again, there's lots of data sets you can use. The easiest way is to use one of the data sets we've already used that's in a collab. But again, there's other fun data sets. I teach this course in the grad level. In the grad level, it's much more of a requirement that your students get use a data set from their own employer, or their, bring in a new data set. But at an undergrad level, you can use one of our existing data sets here. And again, if you want to use a different data set, I can help facilitate that here. Maybe you're interested in some of the cutting edge network or research out there. The Neural IPS conference is this huge conference that's every November here. And so like this last, or December now, fall was this conference. And you can actually look at all the paper sessions, and there's a bunch of visualize or workshops with tutorials and stuff. And then there's also this papers with code that kind of looks at some of the top papers in the recent year out there. So again, if you want to do something like that, basically you can pick any topic you want and from class and do it. It has to be a research paper. You can't do a paper like, oh, I really found the humanoid robots interesting. I'm just going to write a report about one of the robots. It's got to have an experiment and experimental results there. So since we don't have a robot here that you can experiment with, you can't really do a paper on one of the humanoid robots. You've got to have a hypothesis. You've got to have a test. You've got to have results for that. But if you're thinking of image generation and you want to check out gender bias in image generation, you could do that. So we could, you could develop a set of image generation prompts and test them out on different LLMs and figure out how you're going to measure bias or gender with them for that. You can look at any, a lot of students after this class, they get really rich by predicting the Bitcoin price and buying Bitcoin. So that's why we have such a fancy computer lab here, because our past graduates have all been able to get rich with Bitcoin. So you're certainly welcome to predict Bitcoin prices. Because it's such a common thing, I have a worksheet, collab set up for predicting Bitcoin prices if you want to do that. Image generation, image recognition sort of stuff. We just talked about this RAG, breaks documents in, and there's a lot of questions now on, do you really need to use RAG and break a document up into chunks when some of these LLMs have a whole context where you can feed a whole document in there? So can't you just dump a whole document in there and then ask it a question based on a 100-page document? Can an LLM do that? Okay, so again, you've got to figure out something you want to test, hypothesis, and work on that. Now for the paper outline, it's due this Sunday. You've got to basically follow the section of the paper here, but just do the sections in green. So like for the introduction, just write an overview of or some background of your topic. You may not have it. You don't need a thesis yet or anything. Just what do you want to do? Your literature review, find one or two sources that give some background on this topic. And then your simulation or your experiment. How are you going to do your experiment? What data or how are you going to do it? And then again, you should have at least two key sources of information here. Now, so far, we haven't been too picky on sources of information and citations, but that changes in the final paper. We get you can still cite websites, but you need to have multiple peer-reviewed papers, and we'll talk more about that, but on Thursday. But we need to be using more peer-reviewed scientific articles or rather than just a YouTube video. Are you getting excited about the final paper? You're thinking, wow, this is really fun. I'm very excited about the final paper. I'm excited. I love reading these final papers. So, okay. So that's, any questions on the final papers? Try not to use AI to write your whole final paper for that. So you can decide if you want to use AI some, but again, it's gotta, if I can read it and to me, I think you didn't write it, AI wrote majority of it, I will not give you full credit on that. So decide how you want to integrate or use AI for this. Okay. Let's ask some big questions. So I'm going to go to Unit 14. I want you to do the same thing and go to this first thing, this learning resource on big questions on intelligence and stuff. So we're going to try to discuss some of these questions here. We're going to start with intelligence here. We want to know what you think of as far as like, how intelligent are these machines, are these AI models? What do you think the future will bring from these things? And so we're going to use Jamboards today. I don't think we've used Jamboards in this class. So you can click on the Jamboard article link and it just says a question up here, and then you can post your responses here. So again, you can just grab one of these responses and click it and type in something. So that'll be kind of our discussion board over here. So, and I'll try to give you some background and then we'll see if we can get some more opinions on this. So let's talk about just how we measure intelligence, why we would think that a computer might be intelligent. Classically, this has been done with the Turing test, named after Alan Turing here. And it's basically a simulation where you're at a computer and you're typing and you don't know if the person responding to you is a human or a AI. And your job is to tell this, if it's human or not. Today, I think most dating apps are like Turing tests, because I think a lot of the people in some of these dating apps are actually AIs out there. So it's kind of like that sort of stuff. If you're interacting with someone with text, can you tell if this person, the thing you're interacting with is human or not? What kind of questions can you ask of this? Nowadays, with large language models and stuff, we're rethinking this. So like a couple of years ago, also, someone kind of won the Turing test in one of these competitions because they used a computer that pretended to be that English was their second language, so not a good English speaker, and had a little limited background and was from a different country, and so didn't know a lot of questions. And so they were able to fool people because of that interaction. Their English wasn't good, and they didn't know a lot of answers to stuff, but that's what they were able to convince humans that they were real, that the AI was real. But again, and since then, we've really been questioning how useful this Turing test is. One of the things I think we'll talk about some is that, so if something seems intelligent, and everything you do, all your interaction with this person suggests it's intelligent. You can't tell it different from human. Does that mean that thing is really intelligent? Is simulating intelligence the same thing as being intelligent? If I'm up here talking to you and I'm just pretending to be intelligent, but I'm not intelligent, is that really important to you? Is there a difference in that? So, let's just talk about large language models a little bit. So, this is research by Anna Ivanova at MIT. And this research was looking at language and thought in large language models, and in this paper. And looks a lot at, oops, I wanted to open that up in a different window. Let's try this one. How these models, you know, if you look at this more from a language point of view, how can we look at these and what do we see as far as thought and language in these models here? Talks about this functional linguistic competence, being able to put sentences together that made sense there. And formal linguistic competence, you know, knowing this, and then just thought, is there some cognitive ability in here underneath this? And, you know, this difference between speaking and thinking sort of idea. Because it's very easy when you talk to a large language model and responds with English, you know, with language, words and stuff, to attribute a lot of intelligence to these models, where really, you know, the question is, how intelligent are these models? Now, let's go back a little bit and talk about strong AI versus weak AI. Up to just recently, we've mainly been doing what we call weak AI, and that is specific AI. So AI that can play chess. There, you know, the classic example of AI, weak AI, is, you know, a computer game that can beat you, you know, can beat me at chess, but doesn't know, if we had an actual chessboard, how to actually move the actual pieces of the chessboard. It's all symbolic here. Or, you know, a lot of the models we are looking at, we can like, oh, we can find this pattern in this data. We can, you know, predict house prices. We can identify if this image is a cat or a dog. We can do, you know, we have a lot of models that do specific individual things, but they're not necessarily universal there. So if we train a model to identify cat versus a dog, and we show it a giraffe, it's going to try to figure out if it's a cat or a dog. It's not going to know that that is not here. So strong AI, it refers to this kind of systems that have more human-like cognitive or, you know, intelligence. And today we've referred to this as artificial general intelligence. So AGI is a big buzzword today. A lot of people are talking about what is AGI and what it'll be. So here's Amazon's take on artificial general intelligence. And again, they're talking about strong AI compared to weak AI here. They talk about different approaches to intelligence, symbolic, connectionist. This is like neural network sort of ideas here. They talk about deep learning and generative AI and computer vision, robotics, some of the topics we've talked about in this class here. There are a number of agencies like the IMF, is the International Monetary Fund, is, you know, has this thing saying it's likely that artificial general intelligence, that we'll have machines that'll be more intelligent than humans in the next 5 or 10 years. what is that going to mean to the economy and things like that? OpenAI has a blog posting on planning for AGI and beyond here. So what does that mean when we have these intelligent agents that can do, be generally as intelligent as a human? So we don't have that now. Some people say we're not going to get that here. Scientific America back in 2022 was saying, artificial general intelligence is not as eminent as you might think. I also have a link here to Ray Kurzweil's Age of Spiritual Machines. It's often cited as one of the best books looking at, he's a futurist, and so kind of looking at what the world might be like when computers exceed human intelligence here. So what do you think? Will we see computers, AI that is as smart as a high school student, or smart as a college student, or smart as anyone? And how general will it be? Will they be able to answer and do anything there? Will you just have an AI assistant? And what does that mean if you had an AI assistant? So you can either talk or you can post something to this Jamboard. So let's talk. So I want to hear or see one or the other here. So what do you think as far as general intelligence goes? Do you think that would it be nice to have smart machines? You want a smart assistant? Yes?
Be nice.
What would you have the person that the AI do?
I would love one to be able to like walk my dog when I can or when I don't want to. When it's
Right.
raining.
Yes.
Out,
Okay.
and like be able to like play with my dog while I'm gone.
Yeah.
Or, like, clean my house or make me food.
Right. So yeah.
Have a
So
conversation.
then we're talking not just an AI, but also a robot. And it's got to have a physical.
Okay.
It's got to be a physical. We need a humanoid robot to help
I just
there.
really go to get
Right. Okay. In your mind, you're thinking we've got to, yeah, we have to have one or the other. It can't just be a smart car, it's got to be an actual thing.
Smarter, in the sense of more engagement. I don't have to just give it very specific command. Like I could be like, okay, hey, I'm cooking this big cookout for all of these people from like this company from all different places. Like example. Can you find me some recipes that have been used otherwhere, like different things like that, but like it can go really in depth with it.
Right.
So you can pull different recipes, different things, not just give me, here's a couple different resources that you can look at yourself, whereas it would like pull up a bunch of different ones and like help me through the whole entire process.
Yeah. Right.
Stuff like that.
Yeah.
Doesn't necessarily have to have like a physical body or anything.
Right.
Like,
So yeah, you're thinking one just a smart helper, for that, and like voice or screen,
Yeah, voice, screen, both.
Yeah.
Something like you could have both.
Yep. Other ideas?
I'm very concerned about like data safety. Or like if you have like your own AI robot, it would technically record pretty much everything you say, everything you do.
Uh-huh.
Even right now with like regular vacuum, it does have a chip that can record like everything whenever they do it.
Uh-huh.
So like I would be very concerned with them. Like if you have a,
So you don't want companies to get access to this data.
not at all, and like
Yeah,
overall, it's kind of concerning, because if you have a something that you can't technically control,
right.
it's controlled like outside, it can easily, like, the company can, like, that produce this robot, they have access to it 24/7.
Uh-huh.
And technically, either someone can hack into the company and send a special, like, a signal
Right.
that would tell, like, like, for robot to, like, do some harms or anything.
Uh-huh.
So it would be very, like,
Right.
concerning.
So, yeah, so if you're gonna use AI, you'd want a local thing that
Yeah,
that runs on your own hardware that you have control over, that's not necessarily connected, or,
It's just like something that would give me, like, save me this time, like, when it was
Right,
like, work,
yeah.
like, accessing files.
right, yes, right,
It's
because,
pretty much like, kind of like, I think Microsoft out like Power Automate app, when
uh-huh,
you like create different laws and
right,
based on that. you, like,
yeah,
perform different actions.
right, so,
Another nice thing about what we kind of cool is that I feel like we need to implement something like it. For like training, like this more intelligent AI is like on your sites and stuff, allowing whether or not it can like draw data from that or like from that, like have a thing that's like a, I don't know, just like a thing at the top or something saying, you cannot use this for like large language model data or something
uh-huh,
along those lines, so it knows what it's allowed to pull from
right, yeah. So you could have some control over what information was shared or not.
That's one thing I've noticed too, when I've been like looking at art online, is artists now, like, somewhere on the site where they have it posted, they say this cannot be used for image generation or different things
Right,
like that.
yeah,
So underneath, and I wonder if someone with image generation will get that and be like, okay, I can use that, or
uh-huh. Right. I'm looking at some of the posts online too. One thing we're seeing now, current large language models are just trained to predict the next word. And so their model of the world is very word-based here. And so we're beginning to see people study how these language models represent like space and, geography and time here, and can they extract what we call a world model? Do they build a model of the world or have a model of the world that will help them out so that they can think? So, where do they think different geographical, they don't have necessarily a map in their, heads, because they've never been trained on that, but they've been trained on a lot of things about maps here. So how does that all work for things? And so this paper, I worked a bunch of queries and tried to figure out how these language models map the world. And I just did a simple text. I always think it's in like game design, we set up these models, these 3D worlds, and we have a physics engine, and we do the simulation. And so people are saying that maybe we need to be training these AI models to have sort of a physics engine here. So because you have one, you've learned. So if I take this marker and throw it at you, you quickly understand projectile. You don't have, in some ways you kind of do that math in your head, but that's going up and down and spinning, and how you can try to catch it maybe. And your brain has done that and learned that over time. Same with just geography. I asked, I said, you're in a house, you enter the front door, go up the stairs, what room will you find? And it describes the typical setup here. And then I say, okay, assume upstairs there's 3 bedrooms and a bathroom. If you go downstairs and turn right, you'll be in the dining room with views of the kitchen and the living room. If I enter the house and go downstairs, where will I be here? So I'm trying to see, can it build this, framework? And it says, if you enter the house and go downstairs, you would likely find yourself in a basement or the lower level of the house, because I never told it there. And it was smart enough to know that I went upstairs and then I went downstairs, and the kitchen was downstairs. But if I came into the house and go downstairs, that's not the kitchen. I start at that level. And so it does seem to have somewhat, again, this is all language based here and just predicting the words, but we do see these large language models building this. So we are beginning to look at how to build world models, and robots are likely to be one way. Training robots in this world where they are integrating maybe visual and language cues together to build a more complex world model of this. So it'll be interesting to see and there's lots of work at trying to move these LLMs away from just language so they can understand more of the physical world for us. So. I'm still, every once in a while now, I'm stuck in a meeting, particularly a Zoom meeting. I was in a Zoom meeting yesterday for an hour, and these people were talking, and in my head, I'm just thinking, this sounds so much like this person's just a large language model, and just read through this document and I gave it this point of view, and it just reciting these words, and I just see these words rolling off again and again from this person going, can't I just go back and change the prompt a little bit for this person there? So someone was saying that, yeah, are these language models as smart as another person here? A lot of people are beginning to question employment. If we can have AI do all of our jobs, like me, my job is mainly looking, and explaining things about a computer or stuff like that. I don't do any physical stuff generally. How long is it before you don't need me? You're thinking, we don't need you already, Tom, but you're still here. But at some point, do you need a teacher like me in front of this class, or can we, wouldn't it be better to each of you have your own individual tutor in a class like this and walk you through and set things up so I know what you're doing and watch everything you're doing and give you feedback and improve your way. So is my job going away, and is your future jobs going away? And if everyone's jobs going away, what are we all going to do we're all going to take up knitting? I don't really like knitting. I like woodworking. Can we all take up woodworking instead? So, okay, that intelligence isn't too bad. Let's try emotion. Because I want to hear what you think about as far as emotion goes. So we didn't talk about intelligence in animals. So one of the things we often do is talk about like how intelligent is your pet dog or your pet fish there. But let's do that with emotions. Does your pet dog or cat feel emotion here? And so there's been lots of work on, research on animal emotions. It used to be really, not scientific. Animals did not feel emotion or did not have emotions. That's strictly a human thing. Animals never do that sort of research. Back when I, grew up, that was the standard view. Nowadays, there's a lot more work or thought about how animals think and feel for this. Oops, I can't read National Geographic anymore. Okay. And how we see this sort of stuff. Yeah, animal emotions here. there's a whole area of study called effective computing, where we're looking at how how computers can recognize, interpret, and simulate human effects, human emotions. I just saw a couple of videos about the newest chat bot where you could talk to it and it would try to recognize from your face and your voice if you're angry or happy or not. And it just had a number of emotions that would have little scales that say, oh, it looks like you're more this or that, and would try to weigh in, read your emotional state in different areas. So there's a cute article here, and I don't know if you've heard any of the other examples on podcasts or whatever, where people have been, again, dating in a dating app, and they realize that they've been, for the last 3 months talking to an AI, and communicating with an AI and not a person. And again, these are, this is an intelligent New York Times technology writer who realized at some point that they've been chatting with this AI and not the real person that fooled them. So what are your thoughts? We have a new Jamboard here on AI and emotions. Can a robot feel emotions? Can it have empathy? Does your dog have emotion? Does your dog have feelings? Does your cat feel anything but contempt for you? How does that work? So your cat? Dog? Dog? Okay, sorry, I didn't mean to insult you. Okay, dog,
And they definitely have a lot of emotions.
right?
Ripley has crippling anxiety.
Uh-huh,
Like if you leave her anywhere, she gets really stressed.
right,
And she's also like, dogs can like be aggressive and different things like that. Like, then there's Kai, my boxer, who's like he's like just happy to be there.
uh-huh.
Yeah, he just wants to be included. And if you don't include him, he'll cry and cry and cry.
Dogs tend to be very good at picking on your emotional state if you're stressed or relaxed or whatever, in a lot of nonverbal ways. So dogs, are very good at, yeah.
Cats, though.
Yeah, oh,
Friends,
yeah,
cats.
yeah,
It depends on the individual animal itself, because there are 2 cats that I know. One, and Cosmo, he's great. We joke that he has a limited number of brain cells, so like he's very emotional sometimes. Like he'll pick up when you're sad or something. He'll like go down or whatever. Like one of my roommates is sick. He went in and he stayed with him for the entire
yeah,
like kind of thing. But like he knows when he's done something wrong.
right, yeah,
So, like,
guilt,
he has that he'll have that I don't want to say expression, but like his body language will tell you, I know I messed up. Like don't spray me with the water bottle.
yeah, yeah,
Thing. But the other cat has like no thoughts, and like you can. There's nothing going on there. Sometimes sweet emotions, but really like there's just nothing.
Yeah.
Just a blank stare.
right,
She's just there. She just
Yeah.
exists.
uh-huh,
Not really angry. Not really
uh-huh,
happy
Right.
all the time. I guess. Like,
Right.
I think it depends.
yeah. And this gets us into what are human emotions, because we do a lot of talk. I mean, there's areas that study this, but when you start looking at artificial emotions, how much is, we talk about maybe the emotions being controlled by your heart rather than your brain. Well, do we really mean that? And what do we mean by your heart? Because obviously your heart, your physical heart is just pumping blood. That's probably not controlling your emotions. So what do we mean when we say that?
That's what, yeah, that's what I want to bring up. it's like, what's the difference between like, let's say emotions and like just behaviors?
Right.
For like aggressiveness and like fear and stuff, that could just be more of like a biological response to things.
Yes.
Whereas like love and like empathy and stuff like that, that's more of like human emotion, I guess I would say. Kind of.
Uh-huh, right. Yes, how much of emotions are in your brain and how much of them are more of a other physical response there, related to, yeah, other parts of your body. So. And now here's a question we get into. If we have a computer out there that is programmed, or that is trained to show empathy for you. So again, we're not programming it, but it's trained on lots of examples on, in this case, this is how you can show empathy, or this is how you can react in an emotional way. So it's trained to be emotional or respond emotionally. Is that different than an actual human? Is there a real emotions and fake emotions, and is it important? Can a robot or a AI ever really show real emotions, do you think?
Yeah. I don't want to keep this up. But one thing I want, like, I think would be interesting to look at,
Mhm.
is the whole argument of like, a lot of people like looking at this, like, I don't think they can feel emotion. But like, for like the case of empathy, if you raised a kid to be like empathetic, how is that necessarily different from raising a computer to be empathetic, or like programming a computer
Right.
to learn empathy?
Yeah.
Like, would that kid, if you didn't like teach them what like empathy is and how to be empathetic, or would they just naturally be empathetic anyways? Like, is there,
Right.
there's
Yeah.
that kind of argument of how is programming a computer different than raising a child to be
Yeah.
empathetic?
And it's always interesting, I think, that I think people have a wide variety of emotional responses, you know. My wife would describe me as somewhat non-emotional. I'm again more driven by, I guess, my brain or my thoughts there, and I struggle with emotion and expressing emotion there. And she's aware of that and appreciates when I can. And so I think, different people reflect emotions differently. So the question is, yeah, how does that relate to these? And again, you were talking about training, or learning here. Now, is it important, to, when you talk to some robot or some AI, and they have, do you want it to have empathy for you or express some sort of empathy at some time or not? Here. So I keep thinking there's a number of TV show or movies we should watch. I keep like in this emotion, I always think of Her. Have anyone ever watched Her? It's an old movie about a man falling in love with his AI, kind of like Alexa sort of stuff, and all that plays out here. Again, I've been talking, Ashia Khan is over at UMD, and she does a lot with nursing homes and care facilities and looking at, and what they do is they want AI to be emotional, or, show some emotion or show some empathy for people in care facilities. And they think that'll, they'll get better response from the people if emotions are there. So. Okay, we're gonna go a little deeper now. So again, we're going to continue this kind of human, animal, AI kind of spectrum and see where you're at here. And next, we're going to talk about a mind or soul. And do you think, well, let's start with your pets. Does your pet have a soul? Will your dog go to heaven for this? Where are you as far as your pets and a mind or soul? Now you can think of this a couple different ways, and that's why I'm trying to use this mind soul. In my mind, the soul is more of a spiritual thing, and then you're talking more like a life after death, something bigger than your physical being, something kind of beyond science idea here. And then you have this quote here. Christianity has traditionally held that animals have no hope for an afterlife. But then Pope John Paul in 1990 said animals do have souls and are near to God as men are here. Again, so looking at this afterlife or soul idea. Now, mind to me is, and again, we talk about this when we get to consciousness, mind maybe is more of a self-awareness, or, is there some part of your brain where the collectiveness creates some bigger part of you? It kind of relates to this internal dialogue you might have. What, is the sum of all your brain activity more than, something more than just that? Is your awareness more, or your mind, is that more than just the sum of your brain activity in some ways? So have you heard of the Chinese philosophers or a Chinese room argument here? This is an old philosopher's idea. It's a thought experiment that talks about computers and syntactical rules and manipulation of symbols here, and looks at this. Let me bring this up. So the question is that if does a person understand Chinese or can speak Chinese here if they can translate Chinese, sort of idea? And the Chinese room argument here is this idea. So the idea is that, let's say you have a little room with a person in it, and you can write things on a slip of paper and slide it into this person in this room, and they'll write things back and give them back a slip of paper. So just this, it's almost like a chat. You can type in chat to this person and they can type messages back. And your job is to tell, does this person understand Chinese, the Chinese language there? And so you can type in a message or write out a message in Chinese or Mandarin, for example, and send it in, and then they can answer it back. But the question is, does this person understand Chinese? And let's just say that this person doesn't. They just have a couple books, like a Chinese to English dictionary and some other books that they can use to look up the symbols there, and they only speak English. And so all they're doing is taking your symbols, looking them up, translating in English, answering the question in English, and then translating that back to Chinese and writing out a message in Chinese to you for this. And so as far as you can tell, it seems like this person understands Chinese, but the person doesn't. They can just translate it to English, and all their thoughts are done in English here. And the question is that, does this person really understand Chinese? And again, it kind of gets to this thing is, if you can pretend or that you know, have this ability, do you really have the ability? So I'm a big fan of Star Trek, and so there's a good Star Trek episode where they talk about does Data, which is this humanoid robot on Star Trek, does Data have a soul for this, and what does that mean for this? And there's lots of talk about this idea. So yeah, what are your thoughts? Do pets have a soul? Will computers, will AI ever have a soul? Or is that just even not important? Because part of me could just take a counterpoint of view and just say, well, I don't believe in, you know, I don't think humans have a soul. Gesundheit. And I don't think animals have a soul. I don't think computers have a soul. I don't think there is such a thing as a soul. So I take that point of view, that kind of eliminates this whole question. So again, part of this is based on this assumption that, well, do you think humans have a soul? Is there an afterlife, or, you know, is there something beyond us? And again, you can certainly take the opinion that none of these, that this, you know, if you look at it straight from a scientific point of view, you can argue, well, I only are going to believe what science can support. So. Yeah, some good, I think animals have a soul because they're born and they die, show love, so on. Don't think robots do because they don't think for themselves. Don't believe our soul is much similar to us humans. So animals do. Emotions don't have or robots don't have emotions, aren't really alive. So. Okay, we're gonna do one more of these things, and then we're gonna save creativity for next class, because we're gonna do a special activity with creativity. Let's talk consciousness here. So in the last one with the soul stuff, a lot of people are saying robots aren't alive. They don't, you know, they can't think for themselves and they aren't alive and stuff like that. What do we mean by they're not alive? And so to me, that often translates to they're not sentient, or they're not conscious. They don't have a conscious being. So let's talk a little bit about that. And can AI be that? So let's talk, what is consciousness? We've been trying to figure out consciousness for a while and try to understand it from a biological point of view, from a psychological point of view, from a philosophical point of view. There's been lots of discussion of consciousness for a long, long time here. So what is consciousness? What is animal consciousness here? And what might be related to this stuff. So in your mind, what is consciousness or sentience? In my mind, it's kind of some sort of self-awareness or some like internal dialogue that goes on in my head. Is that what you think of? What do you think of when you think of consciousness or sentient.
Definitely like the self-awareness kind of thing. I know not everybody has internal dialogue. That's
Yeah,
something I've like looked into. I have a very, I have a constant internal dialogue, but I also have very like I can picture things very vividly in my head too. So like, even things like I haven't seen, I can like make up things too. Like I have some form of like maladaptive daydream, very hyper realistic, like just visions kind of in my head that I can picture really easily
right.
kind of thing.
Yeah, there's been a lot of, it seems like talk in recent years about different people's internal frame of reference, and you have a spoken internal dialogue. Do you picture things? Different people have different abilities as far as internally picturing or visualizing things. I often notice that with my wife, and we have different abilities as far as visualizing things, in our heads, there. Yeah, and again, some people talk about color and thought or color and words, and how does color play into this sort of idea? So, yeah. So,
Yeah, I can picture like fully like colored like images, even like movie-esque like movement and stuff in my
Right,
head of things
yeah.
that I haven't actually seen.
right.
With different things. Whereas like my friend, she describes it as like just vibes.
Uh-huh.
She can, like, kind of pick up
Right,
vibes in her head, but
right.
not necessarily words.
Yeah. So yeah, what do you think of consciousness? And do you think, how about animals? Are animals aware? Do animals have sentience here? And what's that? So there's this whole thing, dog's inner life, what Robot Pet taught me about consciousness here. On some different articles here. As far as brain research, we've been working a lot on what we call neural correlates of consciousness. So inside the brain, is there some activity, or, when you're conscious, what is that? What does that look like? Is it a pattern of activity in your brain? What does consciousness in your brain look like? And then again, is it important? And then can robots or can AI be conscious or sentient there? And, I start getting this where, like we're just programming these large language models, and I go, well, you just ask it, it generates the next word. But then I set up these AI agents where one agent will be telling another agent to do something and report back. And we have this feedback loop where things are doing, or if you have a robot and some planning activities there, what at some point where, they're working and planning all the time, at some point, does that rise up to a level of sentience or consciousness for things? So yeah, some people think that ChatGPT sometimes seems conscious. Yeah. Yeah, autonomy is an interesting one. Of people say it, an AI doesn't seem to be self-aware, it doesn't have autonomy. And so that would be an interesting thing, is at some point will, right now, if I have a large language model running and I'm not asking a question, it's not doing anything. It's not thinking or stuff like that. But at some point, if we're running this all the time, can we program these, or can we set up these language models so when we're not interacting with them, they're still interacting with us? They're still interacting, thinking, and working on things for this. And is that important? And can it be autonomous? And eventually I want a robot that walks around my house and just looks for chores and does it. So, I want a really good roommate robot where, oh, there are dirty dishes in the sink. I'll clean those up for you and I don't have to tell it. Or, oh, there's, we're low on milk. I'll go to the grocery store and get some more milk for us. And this sort of stuff, and will be autonomous and wander around, do all these tasks I need done. But is that enough to be sentient for this? So AI goes in these spurs where we have lots of interesting developments for a while. And right now we're certainly in an AI explosion. We've had these before. I'm really interested to see if this one, how long this lasts and where we go, and if we see some big improvements in this. As far as these things go, it certainly seems to me like these large language models have a much wider impact than previous AI advancements did. And so it'll be interesting to see. It also seems like we are seeing now, we're kind of at a point where AI advancements are moving much faster than they did even 10, certainly 20 years ago, as far as how quickly new models and how quickly, we're seeing new abilities here. So we're going to wait and do creativity. We're going to spend Thursday on creativity here. So this week, there is no project and no discussion, so you can start working on your final project and work on that outline. You do have to do a explore activity, and what I want you to do is spend 20 or 30 minutes thinking about one of these big questions that we talked about, and doing some research. Find some YouTube videos or some papers or articles about it, and resource it here, and list out the resources you reviewed. What are your thoughts on this topic? Provide an interesting quote and a question. So same sort of format we've had before, but I'm not pointing you at specific things. Oops.
Big question regarding research, like an explore activity. Scroll down, yeah, like this one. No,
This one? Oh,
for us, like at least for me, it says that we're not alone.
oh, okay. Let me change that. It's just supposed to point to this. Yeah, it's pointing to a different class. Let's see. Okay, let's save that. Okay. Try that again. It just points to the same document that we did up here. This same document. So see if you can access it now. So again, you got to do that. And then Thursday, we're going to try to share some creative works that AI, and talk about AI and creativity and what creativity means somewhat here. I encourage you to maybe, if you want to try out some things before class, you can. But in class, we'll have you share like an image generation, have ChatGPT try to write a poem or something like that. I'm interested to see if you have any other areas. So two I've used. One is, oops, I'm gonna open that up in a new window. Has anyone done Suno.ai for writing songs? Okay, so we're gonna do a upbeat country song about how boring Tom's machine learning class is with lots of puns on boring or things and comparisons. Okay, we're gonna generate the song. So again, I'm interested if you're, because I assume your feed is full of this sort of stuff too. So have you done this? In game design, we looked at this Meshy.ai. It can generate a 3D model of an object like this that you can bring into a video game or stuff like that. We tried out and these are certainly the better of the results. Our results were not quite this good. So I don't know, we're not prompting it quite. Yes, our poor leprechaun there. So again, that's an example. So but again, what other things have you seen? So here's our boring song. So we get oops.
Let me tell you, friends, driving the sky. His legs are drawn like a love. I try to stay away, but it's a battle I can't.
Okay, I thought this was the upbeat. That's not upbeat. Okay, let's try this one. That's what I want to be.
No.
These are yeah, to New York. These I was trying to duplicate. There's a song by Kate and Bill. They're Duluth musicians, and they have this song about Minnesotans, two Minnesotans in love and out angling in there. It's all puns about it. So I had it generate. I tried to do a similar stuff. Okay, so that's what I want, some more stuff like that. So we want we'll spend some time Thursday talking about what creativity is, the different types of creativity and that. So if you know of any other ways of creating fun stuff using AI, let me know so we can post it here. So okay. So that'll be Thursday. Okay, so we'll see you on Thursday for that.
Download link for that, for the country song, please.
Okay, well, we'll post the country song. Where is it? Inside that. So here's the, let's see, share. Copy song link, okay. Okay, there's your two country songs. They should be there. See if those will work. I didn't make them public, but I think they'll. As soon as you have the link, it'll work. So, okay, but I'm looking for other things. That you have. So try if you can't try Thursday. See if you can bring other examples of fun stuff we can do for creativity in class. So, all right. So. See you on Thursday.